I wanted to work through an example of a Karnaugh map. So I'm starting with a truth table with 4 inputs, A, B, C, and D, and I've put those inputs in a sort of accounting order. So I can think of this as an 8's place, a 4's place, a 2's place, and a 1's place in the, so A the 8's place, etc., D down the 1's place. And so I can think of these, I'm starting with the numbers 0, 0, 0, 0, and counting up to 1, 1, 1, 1. So I'm going from 0 to 15, 16 possibilities. And I just have some output. It's fairly arbitrary, just some particular output that I say that I want to find an expression for. And specifically, if I'm doing the Karnaugh map, a simple expression for, as simple as can be anyway. And so the first thing I want to do is to take this counting order truth table and put it into this Karnaugh map style truth table over here, in which the inputs are in a gray code order. And then we also work in both rows and columns. And so the starting number here was A was 0, B was 0, C was 0, D was 0. Down here, that is here. And right now, I'm not going to put in the outputs. I'm going to put in the counting numbers just to see their positions. And then I'll come back again and then put in this specific outputs. So, but this is 0, this is 1, and over here is 2. Notice it's 0, 0, 1, 0, that is 2. And then we come back to 3. A is 0, B is 0, C is 1, and D is 1. So they're not in the counting order. They sort of go, they go 0, 1, then you skip over to 2, and you come back to 3. Now here we have 0, 1, 0, 0, that's 4. And that we have the same pattern, 5, and then we skip and come back to 7, 0, 1, 1, 1 with 7. Now the same way we've been skipping in columns, we also skip in rows. So the next one is 1, 0, 0, 0, that's down here, that's 8. And then 9. Skip 10 and come back 11. 1, 0, 1, 1, that was an 11. And 1, 1, 0, 0, that's 12, that's here. 13, skip the column, 14, and then come back. And that makes sense. This guy here, this 15 was A was 1, B was 1, C was 1, and D was 1. So that's the order, this skip and come back. So let me copy this. And sort of then knowing the order, I want to take these out. And fill these in now. Then I know the ordering. I want to fill in the actual outputs and work on my Karnaugh. And I like to sort of group them in 4s and sort of give them a color just to make this blue. And that fills in this first row here. So I'll make that blue. And it was 1, 1, skip 1, and come back 0, 0. And another 4, 0, 1, 1, 0. I'll make that an orange, I guess. And so that was 0, 1, 1, 0. The next 4, I guess I'll make it green. And they go in this, down here in this last row in the Karnaugh map. And so that was 1, 0, 0, 0. And then finally these last 4 here, I guess I'll just leave white. And that was 1, 0, 1, 0. And so that is 1, 0, 1, 0. So there is now my gray coded ordered truth table in rows and columns. So I've rewritten in the Karnaugh style truth table. Now I'm just going to get this out of my way. Now that we have the Karnaugh style, we need to start making groups of 1. Sometimes I call them groups, sometimes I call them blocks. They should be a rectangular. They should be all 1s. they should be of size of a power of 2, so 1 or 2 or 4 or 8, and then we can write an expression for them. So let's pick out ones and put them in groups. So here is, say, this pair of ones going across the top here, and then we always ask, can we put it in a bigger group? Bigger group would give us more simplification. But this 0 down here is blocking us from coming down. There's also a wrapping property, so the first row can be considered next to the last row, but there's a 0 there, so that's blocked, and we can't go horizontally across, and the wrapping doesn't do us any good. It picks up a third one, but that doesn't help us because we want powers of 2, so which 3 is not. So that's as good as we're going to get for these first two up here. So I'm going to just use some way to describe to myself what it is. It's the first row and the first and second column. And what will that be? So the A input for this group, the A input doesn't get a chance to change. So the things that change are what we'll throw away. If it stays the same, then we keep it. And so A is 0 and doesn't have a chance to change. And since it's 0, we prime it. B is also doesn't change. We're only in one row. A and B change as we go down rows, but they don't get a chance to change. They were both 0, so they're both primed. And then the C in these first two columns, C is 0. So that's a C, and because it was 0 prime, the D changes. So that was the simplifying part, and that the D factored out. And so I'm going to just use some notation just to mark, and I've dealt with those two ones. Those ones can appear in other groups, but they don't have to. They are taken care of, so we've accounted for them. If they appear in other groups, that's fine. You're allowed to have overlapping groups. Now I'm looking for my next group. So I can do this here, these two, if I want to have one of those overlapping groups. And so that would be the first and second row. And which column? The second column. So it seems on this one, we're going to have all pairs, and you're only going to get rid of one letter. Okay. So there we have this pair, and the A input does not change. It was 0 in both rows, so it didn't get a chance to change. The B input does change. It's 2 rows. B went from 0 to 1. That's the thing that's going to factor out. It changed. It goes away. The C doesn't change and is a 0, so it's primed. And the D was a 1 and doesn't change, so it's a D. And so I have one more taken care of. And then what? Let's take care of these two. I ask, can they be in a bigger group? If I try to go horizontally, there's a 0. If I try to go vertically, there's a 0. If I try to wrap, that only gets me 3, and I need 4. And if I try to wrap horizontally, I have a 0 over here blocking it. So that's as good as it gets. And that is the third and fourth row. And the first column. And A, for once I've identified the outputs that make up my block, then I look at the inputs, and the A is not changing, and it was a 1. The B is changing, so I throw that away. The C, I'm only in one column. C doesn't get a chance to change, so it's C prime. And the D doesn't get a chance to change, and it's a 0, so it's D prime. Now I've accounted for these two. So now I have these 3 1s over here. And again, 3 1s don't make a group. I can't stretch that into sort of the full column because this is a 0. I don't have a choice in that. I can't go horizontally to the left, and I can't wrap around because of this one. So I'm going to take these 2, and then I'm going to have to come and make another pair of those 2. So first I will do first and second row and the last column. And that's going to be, that's the block. Now I look at the outputs, and now I'm going to look at the inputs and ask who changes and who doesn't. A doesn't change, and it's 0, so it was primed. B does change, so we throw it away. C doesn't change, and it was a 1. And D doesn't change, and it's a 0, so that'll be D prime. And that was these 2. And then I have one more to do, one more block, and that's going to be the second and third row. And the last column. So that is the block. And then after I identify the block of outputs, I look at the inputs that make up that block. And so the second and third row, the A is changing, so that gets thrown out. The B does not change, and it was a 1, so it's B. The C does not change, and it was a 1. And the D does not change, and it was a 0. So my final answer would be to put these all together in sort of a sum of products, but a simplified sum of products. So A prime, B prime, C, no, yeah, A prime, B prime, C prime, there we go, plus A prime, C prime, D, plus, and that pluses are ORs, A, C prime, D prime, plus A prime, C, D prime, plus B, C, D prime. Now, if we've done the Karnaugh map, then we shouldn't have to look for any more simplifications. That's it. The Karnaugh map itself is looking for simplifications. But sometimes people will think that there are more simplifications to be had. So let's look at these ACD terms here. So this ACD, so that A is different because it's primed here and not primed here, and the D is different. The D is not primed and then primed there. So these two don't simplify. Simplification comes when you differ by only one thing, and they differed by 2. What about this ACD and over here ACD? So the C changes. It was prime here and not there, and the D changes. So again, no simplification. What about these two? The A changes and the C changes. So there's always 2 things changing, so there's no simplification. And I really don't have to look if I think that I've done the Karnaugh map correctly, but I just wanted to sort of remind people where the simplification comes from algebraically. And then if we've done the Karnaugh map correctly, its job was to put those things visually together in these pairs. And then if we've seen all the pairs, then we know that we've done our job and completed, made this expression as simple as possible.